everybody, it's Mrs. Denton, and this is the first video in our unit on factoring quadratics. And when we're talking about factoring, we're talking about doing backwards distribution. We are taking something that's written in what's called simplest form, and we're breaking it down into the things that were multiplied together to make that term, those two terms. So first I want to warm up doing a few distribution problems, because when we simplify where there's one term on the outside and multiple terms on the inside, we take that one term and we multiply it to both or all of the items on the inside. So first let's warm up with some distributing, and then we'll start talking about what does backwards distributing look like. So when we distribute this A out, we're saying we're doing A times 3A plus A times 7. We're doing the A on the outside multiplied by both of the terms on the inside, and that simplifies to 3A times A would be A squared, and then 7 as the coefficient in front of A. Now, this can't be simplified any further. You cannot add together 3A squareds with 7A's. They're not like terms. So this is a final product. Check out the second example. We're taking this negative 2 and we're multiplying it by a 1m squared. So negative 2 times 1 is negative 2, with a total of 3 m's in this first term. Then we'll take that negative 2m times a positive 6m. Negative 2 times positive 6 is negative 12. And there will be a total of 2 m's in this term, so m squared. And then finally, we're taking that negative 2m times a negative 1. Well, negative 2 times negative 1 is positive 2, and there's only 1 m in that last term. None of this can be multiplied back or added back together. Each of them are distinctly different terms. So that's a final product. All right, one more example. We've got x's and y's in this multiplication, so let's keep each piece separate. There could be a 1 here as your coefficient if you want to see that value. So first we're going to take the first term out front, 4 times 1. 4 times 1 is 4. Now how many x's total are in this list now? If I cover up the second part. We've got 3 x's over here and 2 x's over here for a total of 5 x's. And how many y's are total in that first set of multiplication? We've got 1 y out front, no y's on the inside, so that is still just 1 y. Now take the coefficient out front and multiply it by negative 2y. 4 times negative 2 is negative 8. Let's list how many x's total. Remember, we're skipping over this x squared right now. So we've got 3 x's out front and no x's inside the multiply there. So that's still just 3 x's. And then we're doing 1 y times 1 more y for a total of 2 y's. Okay, so if that distribution is a little tricky, come see me, because that's kind of what factoring is based off of, that you know how to distribute. So if we factor, we're just doing backwards distribution. We're going to start here and work our way back to the coefficient out front of the parentheses. So let's think about this one. I want you to think, what number could we have multiplied by to get a 4 and an 8 on the inside? So if you think about 4 is just 2 times 2. And if you think about 8 is 2 times 4, which is another 2 times 2. So look at what's in common between 4 and 8. They both have 2 times 2's in there, which means there's a 4 in common. So if there had been a 4 out front to begin with, then the values on the inside, well, 4 times 1 is 4, and 4 times 2 is 8. Now let's think about A. Here there are 2 A's, and here there are 1 A's. So if there had been an A out front, multiplied A times A would give us that 2 A's, and a times no a's would give us that 1a. This is called factored form, and this is our goal. This is what we're shooting for today. You guys, every now and then you come across a polynomial that can't be factored, and we call that a prime polynomial. So if you come across something that can't be factored, we're just going to write prime there so that we can note that it cannot be factored. This type of factoring that we're working on right now is called factoring with a greatest common factor, or shortcut GCF. So let's read through some steps here about how to find the GCF and then how to factor that GCF. There are several factoring methods that we're going to work on, and they kind of all stem from this GCF. So we're going to start with identifying what that is. To factor with the GCF, first you have to figure out what is the GCF, and that might be the toughest step. After that, you're checking your coefficients for a number value, and you're checking your variables, and here's the way to find that. A variable must be present in all the terms to become a GCF. If a variable is present in all terms, take the one with the smallest exponent. And I'll show you what I mean by that. Once we figure out what the GCF is, we're going to divide each term by that value. And then we're going to write our remaining answers in parentheses. We can always check our work by distributing, because remember, we are just doing the backwards of distributing. So I know that's a lot of kind of confusing steps. Let's see it in play. Check out number 1. I'll leave the steps right here on the screen for us. The first thing we need to identify is, what is the GCF? What is the greatest number that can be factored into both of these? So I'm going to step off to the side here. 3 is a prime number. The only thing that we can divide into 3 is 1 and 3. 12 is not prime. There are lots of things that can divide into 12. We can do 12 divided by 1, and that makes 6. That makes 12. We can do 12 divided by 2. That makes 6. We can do 12 divided by 3. That makes 4. All right, now I'm kind of repeating myself. We can do 12 divided by 4, and that makes 3. We can't divide 12 by 5. We'll get a decimal, so I'm skipping 5. We can divide 12 by 6, and that makes 2. And then I can't divide 12 by 7, 8, 9, 10, or 11. That will all make a decimal, so I'm all the way up to 12. 12 divided by 12 makes 1. I'm showing you this in this kind of rainbow format because every factor has a partner. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. Well, when I'm looking for the GCF, I'm looking for the greatest common factor. So greatest means the biggest, and common means what's in both lists. So in this case, the biggest number that's a factor of both 3 and 12 is 3. So my GCF is 3. The directions also tell me to take a look at the variables. It says a variable must be present in all terms to be a GCF. So that kind of gives me a heads up here. There's an x in the first term, but there is no x in the second term. So if that x is not in both terms, it's not part of the GCF. So my only GCF here is 3. So I've identified the GCF as 3. Step 2 says divide each term by that GCF. So I need to divide everything by 3. And leave the remaining factors in parentheses. So if I do 3 divided by 3, I get 1, and there's an x attached to that. If I do 12 divided by 3, that's 4, no x attached to that. And I'm going to write the GCF out front because remember, I am backwards distributing. Here I am saying if I take 3 and multiply it by both things in the parentheses, I'll get back to my original problem of 3x plus 12. Okay, Let's try a second example. Go on down to number 3 with me. The two numbers that we're trying to find a GCF for are 8 and 36. So I'm going to write out what can divide into 8. 8 divided by 1 is 8. 8 divided by 2 is 4. 8 divided by 3 is a decimal, so I'm not including 3. 8 divided by 4 is 2. So it looks like my next factor is going to be whatever multiplies here, which would have to be 8. 8 divided by 8 is 1. So there's all my factors of 8. Now I need to write out all the factors of 36. Anything can be divided by 1. 36 can be divided by 2, that would make 18. 36 can be divided by 3, that would make 12. 36 can be divided by 4, that would make 9. 36 divided by 5 is a decimal, so 5 is out. 36 divided by 6 is 6, so this kind of loops back to itself. 36 divided by 7 is a decimal. 36 divided by 8 is a decimal. 36 divided by 9 goes with 4. So now I'm about to complete this pattern. 3 times 12 is 36. 2 times 18 is 36. And 1 times 36 is 36. So I've got all my factors of 36 written out here. I am looking for the greatest common factor. I'm looking for the biggest number that's in both lists, and that biggest number is 4. So the greatest common factor of 8 and 36 is 4. Okay, now to look at the variables. It says the variable has to be present in all terms. So there's only an m in the first term and only an n in the second term. So there are no variables present in all the terms. So we're not going to be working with a variable here. On to step 2. Divide all those terms by the GCF. So I'm going to divide by 4. 8 divided by 4 is 2. It has an m with it. 36 divided by 4, if you can't do that in your head, we've already done that work right here. 36 divided by 4 is 9 with an n attached to it. These two terms, when multiplied by 4, will form our original problem. And you can check your work by distributing. 4 times 2 is 8 with m. 4 times 9 is 36 with n. Okay, if you're getting the hang of it, start practicing. I'm going to continue working the odds, and you practice on the evens on your own. So flip your page and let's look at some more problems here. Let's take a look at number 5. No, I think I'll scoot on down. I want to slide down the page a little. Let's go down to number 9. Let's slide on down a little. We need to find the GCF of 15 and 30. Okay, a lot of people can do this in their head, but if you can't, just write them out. What divides into 15? Of course, 1 divides into everything. 15 divided by 2 would be a decimal. 15 divided by 3 is 5. 15 divided by 4 is a decimal. 15 divided by 5 is 3. So I'm starting to find the pairs. The next pair isn't going to happen until I get to 15 again. That means everything from 6, 7, 8, 9, 10, 11, 12, 13, and 14 would all form a decimal, and I'm not interested in decimals. Okay, let's list out our factors of 30. Of course, we can start with 1. 30 divided by 2 is 15. 30 divided by 3 is 10. 30 divided by 4 is a decimal. 30 divided by 5 is 6. 30 divided by 6 is 5. So I just found that first pair. Let's get the second pair. 3 times 10 is 30. 2 times 15 is 30. And 1 times 30 is 30. So the greatest common factor is the largest number in both lists, which is 15. I can divide 15 and 30 by 15. And now I need to check out my variables. Let's look at A first because there's an A and a B here. There are 2 A's in the first term and there's 1 A in the second term. So for the first time, we have variables in both terms. My directions say, if a variable is present in all terms, take the one with the smallest exponent. Okay, so in the first term, A has an exponent of 2. In the second term, A has an exponent that's invisible, but there would be a 1 right there. So I'm going to use 1A as the GCF. Okay, there's also a B in both terms. This is B to the power of 1, and this is B to the power of 1. So the common factor is also B to the power of 1. All right, so let's go through and divide by our GCF. 15 divided by 15 is 1. If there are 2 A's in the numerator and 1 A in the denominator, check out what happens. A over A. One of the A's cancels out, and there's 1 A left. If I'm dividing B over B, both of those B's cancel out, so there are no B's left. Now to the second term. 30 divided by 15 is 2. The 2 A's here would cancel each other off, and the 2 B's would cancel each other off. So this is the quotient after dividing off the GCF. To check your work, distribute this back out. 15 times 1 is 15. A times A is A squared. B times no B is a B. 15 times 2 is 30. A times no A is an A. And B times no B is a B. You can always check your work by distributing. All right, I'm going to slide down a little bit further. Take a look at 13 here. 13, I'm supposed to find something that divides into 5 and 13. So let's list out our factors. 5 can be divided by 1 and 5. That's it. Everything else would be a decimal. 13 can only be divided by 1 and 13. Everything else is a decimal. So the biggest number that can be divided into both items is just 1. Now looking at our variables. There's an x in the first term, but no x in the second term. So we cannot factor out an x. There's a y in the second term, but no y in the first term. So we cannot factor out a y. So our only GCF here is 1. You guys, I want you to think, what happens if you divide something by 1? 5 divided by 1 is still 5 with an x attached to it. 13 divided by 1 is still 13 with a y attached to it. So this is a prime polynomial. It can't be factored. Factoring out a 1 does not change the problem. Okay, one more example to do together. Let's come on down to 17. We need to factor out from 3 terms. So I need to find the greatest common factor of 6, 14, and 10. So I'm going to list out all my factors of each so it makes it clear to see what the GCF is. I can divide 6 by 1 because that's 1 times 6. 6 divided by 2 is 3. 6 divided by 3 is 2. So there's my first pair. So my next pair would be 6 times 1 makes 6. So there are 4 factors that can divide into 6. For 14, I can divide by 1. 14 divided by 2 is 7. 14 divided by 3 is a decimal. 14 divided by 4 is a decimal. 14 divided by 5 is a decimal. 14 divided by 6 is a decimal. 14 divided by 7 is 2. So I've found a pair so I can finish out this list a little faster. 1 times 14 is 14. Okay, I need to do it one more time for this 10. I can always divide by 1. 10 divided by 2 is 5. 10 divided by 3 is a decimal. 10 divided by 4 is a decimal. 10 divided by 5 is a whole number 2, so there's a pair. So I can complete my list now. 1 times 10 is 10. So I'm looking for the GCF. I'm looking for the greatest number in all three lists. And the biggest number in all three lists is a 2. So the GCF here is going to be a 2. I can factor a 2 out from each term. Now let's look at our variables. Each term has y's in it, y to the fourth, y to the third, y squared. My hint in my notes is to find the one with the smallest exponent. So here the smallest exponent is y squared. Once you identify the GCF, divide everything by that value. 6 divided by 2 is 3. If I divide out 2 y's, watch what happens. Y to the fourth over y squared. 2 of the y's cancel out, and 2 of the y's remain for a y squared. Next term, 14 divided by 2 is 7. 3 y's on top, 2 y's on bottom, 2 of them cancel out, 1 remains. So this 7 has a y attached to it. Last term, negative 10 divided by 2 is negative 5. 2 y's on top and 2 y's on bottom, everything cancels out, so there are no y's left in that division. So my polynomial division is finished, and my GCF out front is 2y squared. You can check your work by distributing this back together, and you should come up with our original problem. Okay, you guys, keep practicing. Come see me if you need help, and then check all these answers against the answer key so you can see how you're doing. Happy studying!